Hello and welcome to Vision Academy. In this video, we are going to learn binary subtraction using 1's and 2's complement. Now, let us begin with the binary subtraction using 1's complement. Here, there are two cases. Let us begin with case number one, subtracting a smaller number from a larger number. That is, minuend is greater than the subtrahend. Now, let us take an example. Right here, 25 minus 13. So here I should get 12. So let us convert both of these two numbers into its binary equivalent. I'll write here 25 to divide this decimal number by 2 and note down quotient and remainder till the quotient becomes 0. We have to divide this number by 2. 2 ones are 2, 2 twos are 4, remainder is 1. 2 6 are 12, remainder is 0. Next, 2 3s are 6, remainder is 0. 2 1s are 2, remainder is 1. So we cannot divide 1 by 2. So as per basic mathematical rule that says when the numerator is less than denominator, then the numerator act as a remainder and quotient becomes 0. So here first remainder is called least significant digit and the last remainder is called most significant digit. So we will have to write the decimal equivalent of this binary number from most significant digit to least significant digit. So in front of 25, I have to write now 1, 1, 0, 0, 1. Now let us convert this 13 into its binary equivalent. Here I'm going to write 13 and divide this number by 2. 2 6 are 12, remainder is 1. 2 3s are 6, remainder is 0. 2 1s are 2, remainder is 1. And now similarly we'll write here quotient 0 and remainder is 1. Here you can find in case of number 25 there are 5 binary numbers, and in case of 13 we have got only 4 binary digits. So let me write the first remainder is called least significant digit and the last remainder is called most significant digit. So we will have to write it from bottom to top. So here, in order to match the number of columns in both minuend and subtrahend, what we have to do is we have to add one leading 0 first. Then I have to write 1 1 0 1. Here I'm going to write 1 1 0 1. So in binary, what we are going to get here, right? So first number, that is called minuend, and the second number is called subtrahend. Now let us begin with first step. Find 1's complement of the subtrahend. How do you find 1's complement? I'll write here 1's complement of the subtrahend is what? 0 1 1 0 1 is, here I'm going to convert 0 to 1, 1 to 0. Here bit number 0 is present, I'm going to write 1, and here two bit number 1's are there, I'm going to write 2 zeros, and next we have got 0. In place of 0 you write 1, and in place of 1 you can write 0. Now let us go for second step. Add this to minuend. What is minuend now? Here I'm going to write minuend 1 1 0 0 1. Now we have to add this 1's complement to this minuend. I'm going to write here 1 0 0 1 0. So add this one from the right hand side. 0 plus 1 is 1. 0 plus 1 is 1. 0 plus 0 is 0. 1 plus 0 is 1. 1 plus 1 is 2. Here 2 can be written as 1 0. So let us prove that one. Here I'm going to write 2. Divide this number by 2. 2 1s are 2. Remainder is 0. Again divided by 2. 2 zeros are, and this one will become the remainder. Here the first remainder is called least significant digit and the last remainder is most significant digit. So we will have to write it from bottom to top. So here 2 is nothing but what? 1 0. So you can see here we got the carry, right? So third step says that carry is generated. This carry is called end around carry. Add this carry back to LSD to get the final difference, right? So this bit number, leftmost bit number 1 is called carry. So either you can write 0 or you can leave it. So here I'm going to write 0, 1, 0, 1, 1. Next, this 1 is to be added down to LSB here, right? So I'm going to write it here 1 plus and go for adding it. 1 plus 1 is 2. 2 can be written as, just now we have studied, 1, 0. So here I'm going to write carry 1 and sum is 0. So 1 plus 1 is 2 again, carry 1 and 0 is the sum. So 1 plus 0 is 1. So this 1 as it is, and this 0 if you want to write, you can write, otherwise you can leave it. Now we have to check whatever we got here in the form of binary notation, whether it is correct or not, whether it is equal to 12 or not, we have to check. So how to do that? We can go for verification. I'm going to write here verification. So how do you verify? So I'm going to multiply the positional weight of each of these bits from the right hand side. So I'll start counting from the right hand side. 0 is in its 0th position. 0, 1, 2, 3. So this bit number 1 is in its 3rd position. So what I'm going to do here is I'm going to write 1 into 2 to the power 3. Next plus. Next we have got bit number 1. 1 into 2 to the power 2. Plus next we have got two zeros. 0 into 2 to the power 1 plus next is 0 into 2 to the power 0. So let us further simplify. Here 2 to the power 3 can be written as 2 is to be multiplied 3 times. 2 2s are 4, 4 2s are 8, 8 1s are 8. So here I'm going to write 8 plus 2 to the power 2 is to be multiplied twice. 2 2s are 4, 4 1s are 4 plus 0 into 2 to the power 1 is 0 plus 0 into 2 to the power 0 is also 0. You can see here 8 plus 4, that gives us 12. So that is absolutely correct. Now let us begin with case 2, subtracting a larger number from a smaller number, that is minuend is lesser than the subtrahend. Now let us take an example here. I'll write 15 minus 31. So here I should get minus 16. So let us convert this 15 into its binary equivalent. So divide this number by 2. 2 sevens are 14. 1 is the remainder. 2 threes are 6. 1 is the remainder. 2 ones are 2. 1 is the remainder. And as per basic mathematical rule that says when the numerator is less than denominator, then the numerator act as a remainder and quotient will become 0. So first remainder is called least significant digit and the last remainder is called most significant digit. So we will have to write the binary equivalent of this number, that is 15 is the decimal number whose binary equivalent number is 1111. So here I'm going to write 1 1 1 1. Now let us convert 31 in its binary equivalent number. I'll write here 31 divided by 2. 2 ones are 2, 1 is the carry, it will become 11. 2 5s are 10, 1 will become the remainder. 2 sevens are 14, 1 is the remainder. 2 3s are 6, 1 is the remainder. 2 1s are 2, 1 will become the remainder, again divided by 2. So here quotient will be 0 and 1 will become the remainder. So first remainder is called least significant digit and the last remainder is called most significant digit. So we will have to write it from bottom to top. Here you can observe that in decimal number 31 there are 5 binary digits, and in case of 15 we have got only 4 binary digits. In order to match up with the number of columns, for 15 we are going to write one leading 0 to make it 5 bits. Now so all these 5 bits I'm going to write below here 1 1 1 1 1. So what I'm going to get over here, so first number is called minuend. and the second number is called subtrahend. Now let us continue with the first step. Find 1's complement of the subtrahend. We need to find 1's complement. So how to find it? We will write 1's complement of the subtrahend is what? 5 times 1 is. So here 1's complement can be determined by changing bit number 0 to 1, 1 to 0. So here all the bits are 1's. You can make them 0. So here 5 zeros represent 1's complement of the subtrahend. Step 2 says add this to minuend. Minuend is what? 0, 1, 2, 3, 4 bits. Next 0 is to be added. So 5 zeros add. So what you are going to get here? You're going to get the same result 0, 1, 1, 1, 1. Now no carry is generated, correct? Recomplement the answer to get the final difference. Here there is no carry, so we need to recomplement the answer. Means what? Once again you need to convert binary digit from 0 to 1, 1 to 0. I'm going to write here 1's complement of this number, that is 0, 1, 1, 1, 1 is. You can convert from 0 to 1, 1 to 0. So here you can see the bit 0, it will become 1, and all 4 1's are set to zeros. So we got 1 4 times 0. We have to check out that whether it is correct or not, whether it is going to be 16 or not. One more important point is we need to put minus sign in front of it, right? So that is one point that is to be noted. So here I'm going to write minus 1 4 times 0, and now we have to cross verify whether it is equal to minus 16 or not. Here I'm going to write verification. So how to do it? You can start counting from the right hand side the positional weights of each binary digit. So from the right hand side, the positional weight of this 0 is 0, 1, 2, 3, 4. That is 2 to the power 4 into 1. Next bit is what? 0. We have got 4 zeros. I'll write 0 into 2 to the power 3. Next 0 into 2 to the power 2. Next bit is 0 into 2 to the power 1 plus 0 into 2 to the power 0. Now let us further simplify. So 2 to the power 4 means we have to multiply 2 4 times. So 2 to the 4, 4 to the 8, 8 to the 16. Here I'm going to write 16. 16 ones are 16 plus 0 into 2 to the power 3 is 0 plus 0 into 2 to the power 4 is 0 plus 0 into 2 to the power 1 is also 0 plus 0 into 2 to the power 0 is also 0. Here you can see we got 16. So whatever we got in binary number, that is absolutely correct. Now let us continue with binary subtraction using 2's complement. Case number 1. Subtracting a smaller number from a larger number, that is minuend is greater than the subtrahend. So let me take example over here. I'll write 51 minus 25. So it should give me plus 26. So let us convert both of these two number into its binary equivalent. So first I'm going to write 51 divided by 2. 2 2's are 4. 1 is the carry, it will become 11. 2 5's are 10. 1 will become the remainder. 2 1's are 2. 2 2's are 4. 1 is the remainder. 2 6's are 12. 0 is the remainder. Next 2 3's are 6. 0 will become the remainder. Again divided by 2. 2 1's are 2. 1 is the remainder. 2 zeros are, and this 1 will become the remainder. Here it is called least significant digit, that is the first remainder, and the last remainder is called most significant digit. So we will have to write the decimal equivalent of this binary number from most significant digit to least significant digit. So here 51 can be written as 1 1 0 0 1 1. Now let us convert 25 into its binary equivalent. Here I'm going to write 25, divide this by 2. 2 1's are 2, 2 2's are 4. 1 is the remainder. 2 6's are 12. 0 will become the remainder. 2 3's are 6. Here 0 will become the remainder. Again divided by 2. 2 1's are 2. 1 is the remainder, 2 zeros are, and this one will come over here. And the first remainder is called least significant digit, and the last remainder is called most significant digit. So we will have to write it from bottom to top. Here you can observe that in case of 51, we have got 6 binary digits, and in case of 25, we have got 5 digits. In order to match up with the number of columns, I have to take a leading 0 here. Then I have to write 1 1 0 0 1. Here, what we are going to get in binary notation. The first number is called minuend, and the next number is called subtrahend. Now, let us continue with the first step. Find 2's complement of the subtrahend. So how to find 2's complement? I'll write here 2's complement of the subtrahend. So subtrahend is what? 0 1 1 0 0 1 is 1's complement plus 1. That gives us 2's complement. So how to find 1's complement of this subtrahend? By converting 0 to 1 and 1 to 0. Here you can see the leftmost bit is 0. We are going to write here 1. And the next bit is 1 1. I'm going to write 0 0. Next bit, 2 bits are 0 0. I'm going to write 1 1. And the last bit is 1. I'm going to write here 0. And this plus 1 as it is. Next, after addition, what we are going to get here? We are going to get 1 0 0 1 1. 0 plus 1 will become 1. Now we will go for second step. Add this to minuend. I'm going to write minuend 1 1 0 0 1 1 over here. I'll write 1 1 0 0 1 1. Next, take this 2's complement and add it to minuend. I'm going to write here 1 0 0 3 times 1. Add it from the right hand side. 1 plus 1 is 2. 2 can be written as 1 0. We have already discussed about this one. So 1 plus 1 is 3. So 3 can be written as 1 1. So we can check out that how exactly it is possible. So divide 3 by 2. 2 1s are 2. 1 is the remainder. 2 zeros are, and it will become the remainder. Here the first remainder is called least significant digit, and the last remainder is called most significant digit. So we will have to write it from bottom to top. So here 3 is equal to what? 1 1. Correct? So here 1 plus 1 is what? 3. 3 can be written as 1 1. So 1 is carry and 1 will become the sum. Again 1 plus 1 is 2. 2 can be written as 1 0. Next, 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 1 is what? 2. 2 can be written as 1 0, because I cannot take this carry on the left hand side because we don't have any other columns on the left hand side. Now let us go for step number 3. Carry is generated. You can see the last bit, leftmost bit is called carry. This carry is called end around carry. Discard this carry to get the final difference. Discard means what? You can just leave it off and you can write the remaining bits. So you can write 0 1 1 0 1 0. So this leftmost bit 0 you can write, otherwise you can leave it. Now we have to verify that whatever the answer we got in the form of binary notation, whether it is 26 or not. So how to do that? We'll go for verification. I'll write here verification. So we are going to check out the positional weights of each bit of this binary number. So the positional weight of this 0 is 0 1 2 3 4 5. So here I'll write 0 into 2 to the power 5 plus. Next we have got bit number 1 into 2 to the power 4 plus. Next we have got bit number 1 into 2 to the power 3 plus. Next we have got 0 into 2 to the power 2 plus. We have got bit number 1 into 2 to the power 1 plus. Last bit is 0 into 2 to the power 0. Now let us further simplify. 0 into 2 to the power 5 is 0 plus 2 to the power 4. 2 is to be multiplied 4 times. 2 2s are 4, 4 2s are 8, 8 2s are 16. Now I'll write here 16 1s are 16 plus 2 to the power 3 means we have to multiply 2 3 times. 2 2s are 4, 4 2s are 8, 8 1s are 8, plus 0 into 2 to the power 2 is 0, plus 2 to the power 1 is 2, 2 1s are 2, plus 0 into 2 to the power 0 is 0. Now let us simplify. 14, sorry, 16 plus 8, it will become 24. 24 plus 2 is 26. So whatever we got in binary notation, that is matching with the answer. Now let us begin with binary subtraction using 2's complement. Case 2, subtracting a larger number from a smaller number, that is minuend is lesser than the subtrahend. Let us take an example. Here I'm going to write 35 minus 55. So I should get here minus 20. So let us convert both of these two numbers into its binary equivalent. First of all, I'm going to write 35, divide this number by 2. 2 ones are 2, 1 is the carry, it will become 15. 2 sevens are 14, 1 is the remainder. 2 eights are 16, 1 is the remainder. 2 fours are 8, 0 is the remainder. 2 twos are 4, 0 is the remainder. 2 ones are 2, 0 is the remainder. So as per basic mathematical rule, when the numerator is less than denominator, then the numerator act as a remainder and quotient will become 0. So here I'm going to write the first remainder is called least significant digit and the last remainder is called most significant digit. So I will have to write it from most significant digit to least significant digit. So here in front of 35, I have to write here 1, 0, 0, 0, 1, 1. Now let us convert this 55 into its binary equivalent. I'll write here 55, then divided by 2. So 2 twos are 4, 1 is the carry, it will become 15. 2 sevens are 14, 1 is the remainder. 2 ones are 2, 2 threes are 6, 1 is the remainder. 2 sixes are 12, 1 is the remainder. 2 threes are 6, here 0 will become the remainder. 2 ones are 2, 1 is the remainder. 2 zeros are, and this one will become the remainder. So first remainder is called least significant digit and the last remainder is called most significant digit. Here you can check out 2, 4, 6 digits are there, and here also we have got 6 digits. Now let us write it from the bottom. So here I'll write most significant digit to least significant digit. I'll write here 1, 1, 0, 1, 1, 1. So what exactly we are going to get in binary notations? Here the first number is called minuend, which is less than that of the subtrahend. The next number is called subtrahend. Now let us go for first step. Find 2's complement of the subtrahend. So how to do it? I'll write here 2's complement of the subtrahend can be determined by finding out 1's complement and adding 1 to it. You will get 2's complement. I'll write here 2's complement of subtrahend is what here? 1, 1, 0, 1, 1, 1 is 1's complement plus 1. So here I need to find 1's complement of this number. So you can convert 1 to 0, 0 to 1. So what I'm going to do here is I'm going to write in place of 1, I'll write 0. Next bit is also 1, I'll write 0. Next bit is 0, I'll write 1. So next 3 bits are 1s, I'll write 3 zeros and plus 1. Now let us add this. So what we are going to get? 0, 0, 1, 0, 0, 0 plus 1 is 1. Now let us go for step number 2, add this to minuend. What is minuend? 1 triple 0 1 1. I'll write here 1 triple 0 1 1. So add this 2's complement to this minuend. I'll write here 0 0 1 0 0 1 plus sign. So start adding from the right hand side. 1 plus 1 is 2. 2 can be written as 1 0. 1 plus 1 is 2 can be written as 1 0. So here 1 plus 0 plus 0 is 1. 0 plus 1 is 1. 0 plus 0 is 0. 1 plus 0 is 1. Step 3. No carry is generated. Recomplement the answer to get the final difference and put minus sign in front of it. Here we need to recomplement it. Recomplementation means what? We have to find 2's complementation, right? So right here 2's complement of what it is 1 0 1 1 0 0 is 1's complement, correct? Here I'm going to write 1's complement plus 1. So 1's complement means what? Convert bit number 0 to 1, 1 to 0. So here I'm going to write 0 1 0 0 1 1 plus 1. So here you can see 1 plus 1 will become 2, carry 1, it will become 0. Otherwise you can write it over here something like this: 0 1 0 0 1 1 plus 1. 1 plus 1 is 2. 2 can be written as 1 is carry, 0 is sum. 1 plus 1 is 2, can be written as carry 1, 0 is the sum. 1 plus 0 is 1. Next, this 0 as it is, this 1 as it is, and this 0 as it is. So here we got uh, the 2's complement and the final difference. Here in front of it, we are going to write minus sign: 0 1 0 1 0 0. So I have to check out that whether this particular number is equal to that of this 20 or not, right? So what to do for that? I have to go for verification. I'll write verification. So how to verify? You can count the positional weights of each of these binary digits from the right hand side. So positional weight of this 0 is 0 1 2 3 4 5. So I'll write here 0 into 2 to the power 5 plus, next we have bit number 1. Here I'm going to write 1 into 2 to the power 4. Next we have got bit 0 into 2 to the power 3 plus we have got bit number 1 into 2 to the power 2 plus we have got two zeros, right? So here I'm going to write 0 into 2 to the power 1 plus 0 into 2 to the power 0. So 0 into 2 to the power 5 is what? 0 plus 2 to the power 4 is what? 2 to the 4, 4 to the 8, 8 to the 16. So 16 into 1 is 16 ones are 16 plus 0 into 2 to the power 3 is 0 plus 2 to the power 2 is 4, 4 ones are 4 plus 0 into 2 to the power 1 is 0 plus 0 into 2 to the power 0 is 0. Now you can see 16 plus 4, that is 20. So whatever we got here, it is matching with that of the result. Hence, it is absolutely correct.